The buttery, flaky croissant, once a humble treat from French cafes, has become a global breakfast icon. But how do massive factories recreate that delicate, handcrafted charm on such a huge scale? The secret lies in modern automation, cold proofing, and precision baking. The packaged croissant market is booming, projected to hit $13.7 billion by 2030, with demand rising fast in Asia and North America. In this video, we'll explore how croissants go from raw dough to golden, crispy perfection inside high-speed production lines. Ready to uncover the secrets behind your favorite pastry? Then stay connected and don't forget to like and subscribe to our channel for the latest updates. Croissant factories rely on precision when it comes to ingredients. The core ingredients include high-gluten wheat flour, purified water, fresh yeast, salt, premium butter, and sometimes sugar or milk solids for flavor. Industrial-grade storage silos house flour and other dry goods under climate-controlled conditions. Liquid ingredients like water and eggs are pumped into mixers through sanitized pipelines. Each ingredient is weighed using automated batch systems, minimizing human error. Butter, crucial to croissant texture, must have 82 to 84% fat content to meet industry standards. Quality ingredients not only enhance taste, but also ensure consistency. Some factories use clean label ingredients to meet modern consumer demand for preservative-free and additive-free products, marking a growing trend in healthy baking. Once the ingredients are measured, the dough-making process begins. In massive spiral or horizontal mixers, ingredients are blended into a homogeneous dough over 10 to 15 minutes. During this time, gluten starts developing, giving the dough its strength and elasticity. Temperature control is essential, ideally between 20 to 24 degrees Celsius, to activate the yeast without overheating the mix. After kneading, the dough is left to rest in bulk containers for about 20 to 30 minutes. This fermentation period is vital for flavor development. Unlike traditional bakeries, factories optimize this phase using climate-controlled rooms. The mixed dough now becomes the base for lamination, the process that gives croissants their flaky layers. Lamination is the most critical step in croissant production. Here, the rested dough is flattened into large sheets and layered with blocks of chilled butter using mechanical rollers. The butter should be at 5 degrees Celsius to prevent melting during the process. The dough is then folded over the butter and rolled out again, repeating this step 3 to 4 times to create up to 81 layers. These folds form alternating sheets of dough and butter, essential for the flaky, airy texture. High-end laminators can process several hundred kilograms per hour, maintaining consistent thickness and temperature. The key challenge? Keeping the butter cold yet pliable. Any melting ruins the layer formation, affecting the texture after baking. Once laminated, the dough enters the sheeting phase. Industrial sheeters stretch the dough into long, thin sheets, usually down to 3 to 5 millimeters in thickness. Sensors monitor and adjust roller pressure in real time, maintaining a uniform sheet. At this stage, the dough can span dozens of meters on conveyor belts. Advanced machinery like Rion or Rondo lines uses servo motors and memory systems to calibrate each batch, ensuring consistent output regardless of size. Automation helps minimize waste and boosts efficiency, especially during high-volume operations. These precisely sheeted dough ribbons are now ready for cutting into the signature triangle shape before being curled into crescents. With sheeting complete, high-speed cutters carve the dough into perfect isosceles triangles using rotary or guillotine blades. The size of each triangle determines the final croissant's size and weight. Standard sizes range from 45 grams to 80 grams per unit. At this stage, factories may insert chocolate sticks, almond paste, or cheese into the triangle base, preparing filled variants. Once cut, triangles move to the curling machines, which gently roll them into their crescent shape. Some croissants are shaped manually in smaller facilities, but large-scale factories rely on robotic arms or belt guides to complete shaping with high-speed precision. Each piece is then spaced on baking trays or trays for proofing. Before baking, croissants must rise, which is known as proofing. Industrial proofing chambers create an ideal environment of 28 to 30 degrees Celsius and 75 to 80% humidity, where yeast ferments and dough rises. This process usually lasts 1 to 2 hours. Proper proofing activates the yeast, enhances flavor, and preps the butter layers to steam during baking. Underproofed croissants won't rise properly, while overproofed ones collapse. Monitoring this phase closely is essential to achieving the perfect texture and appearance. Once proofed, trays of croissants move to high-capacity tunnels or rack ovens. These ovens maintain steady heat, usually around 180 to 200 degrees Celsius, for 15 to 20 minutes. The butter layers steam during baking, separating the dough into hundreds of thin sheets and giving it the signature flakiness. Inside, the dough cooks soft and airy, while outside, a crisp golden crust forms. Some factories apply egg wash before baking for extra shine. Others use steam injection to boost lift and improve crust formation. Brands like MIWE or Bongard lead in industrial baking systems, offering custom bake profiles to suit different recipes. Once baked, croissants are gently cooled on conveyor belts. Croissants must cool to room temperature, 20 to 25 degrees Celsius, before packaging. If packed while warm, condensation can make them soggy and promote mold. Cooling lines use long spiral or tunnel systems that move baked goods slowly through ambient or chilled zones. This phase usually lasts 30 to 45 minutes, depending on the batch size and croissant type. High-volume operations often deploy UV sterilization along conveyor belts to reduce microbial risks during open exposure. Cooling is one of the final stages where product quality can be lost or preserved. Once cooled and checked, the croissants proceed to inspection and packaging. Factories use automated vision inspection systems and human QC inspectors to check for shape, color, weight, and uniformity. Machines equipped with cameras and AI software scan each croissant in milliseconds. Products outside tolerance limits, misshapen or underbaked, are removed automatically. Metal detectors and X-ray scanners ensure no foreign particles are inside. Some plants use inline moisture analyzers to measure interior hydration, ensuring texture is within specification. This stage ensures food safety standards such as HACCP, ISO 22000, and BRC global standards are met, which are mandatory for export-grade production. Consistency, hygiene, and taste must meet brand benchmarks before packaging. After quality checks, croissants are fed into packaging lines. Flow wrapping machines wrap individual or grouped croissants in foil or plastic sleeves, sometimes in modified atmosphere packaging to extend shelf life up to 30 days. Labels include expiration dates, batch numbers, and nutritional info, often in multiple languages for international markets. Some factories now use biodegradable packaging to meet sustainability goals. Global players like Grupo Bimbo and Lantmen and Unibake are leading in packaging innovation, combining speed with environmental responsibility. Once wrapped, croissants are boxed and stacked onto pallets, ready for cold or ambient storage. Frozen croissants are revolutionizing the bakery industry. After shaping or proofing, they're quickly par-baked or frozen at -40 degrees Celsius to lock in freshness for up to a year. These croissants are shipped via cold chain logistics using insulated, temperature-controlled vehicles, enabling cafes and hotels worldwide to bake them fresh on-site. This frozen bakery sector is projected to hit $25.4 billion by 2027. Meanwhile, the future of croissant production focuses on healthier recipes, automation, and sustainability. Demand for low-sugar, vegan, and gluten-free options is driving research into plant-based ingredients. Robots and AI are improving efficiency, hygiene, and dough precision. Factories are going green with energy-saving ovens, recycled water systems, and eco-packaging, ensuring croissants stay globally loved while meeting modern needs. From handmade delicacies to globally distributed pastries, croissants have come a long way. What hasn't changed is their magical texture, buttery flavor, and irresistible aroma. Today, advanced machines and meticulous processes ensure millions of croissants roll out of factories every day, uniform, safe, and delicious. As the world demands healthier, more sustainable options, croissant factories are rising to the challenge with smart tech, clean labels, and greener operations. So, next time you bite into a golden, flaky croissant, remember the sophisticated journey it took from field to factory to your plate. Curious about how other iconic foods are made? Like, share, and subscribe to our channel for more delicious insights.